Tonight, we begin our journey through the quiet, shimmering river of stars that forms our home, the Milky Way. Imagine yourself standing beneath a velvet sky, its darkness stretching outward like a boundless ocean, while a soft breeze moves across unseen cosmic shores. Overhead, faint pinpricks gather into a gentle mist of light, so distant and ancient that the photons reaching your eyes began their travels long before humans learned to dream. Let us set forth on this tranquil path among the stars, a path that winds through clusters, nebulae, glowing arms, and silent cosmic currents. With each step, we drift a little farther into understanding, and a little deeper into rest. For tonight, knowledge arrives not as sharp facts, but as calming waves, soft truths carried through celestial space. Breathe slowly, for the universe has been waiting a long time to tell its story. Before we wander too far into this luminous river, I invite you gently to support this growing channel. Your subscription helps us reach our first 1,000 travelers, allowing these meditative science journeys to continue flowing across the night. If you feel moved to do so, consider liking, subscribing, or sharing this quiet corner of the cosmos with someone who could use a moment of calm. Thank you for being here as we drift deeper into the Milky Way. The Milky Way unfurls around us, like a spiral galaxy painted in slow motion, its arms tracing arcs of starlight that curve gracefully through dark matter's unseen framework. To begin, picture the Sun as just one of hundreds of billions of stellar companions orbiting the galactic center with patient determination. Each star has its own story, its own age, its own temperature and brightness. Some burn with youthful blue fire, blazing hot and short-lived. Others glow with steady yellow warmth, like our sun, living long and comfortably in their middle age. Still others are ancient red giants or fading dwarfs, cooling into quiet retirement. And yet, from our vantage point on Earth, they blend into a soft river of light, giving the illusion of continuity where distance and emptiness actually reign. The Milky Way's glow is simply the combined murmur of these separate suns. Imagine them as a distant choir, each voice faint alone, but harmonious together, singing a cosmic lullaby across interstellar space. You might imagine yourself drifting upward, leaving Earth behind. The blue marble shrinks, and the sun becomes a dot among countless dots, yet every one of them is a furnace sculpting matter into heavier elements, seeding the galaxy with the potential for planets, oceans, and life. The quiet grandeur of it all wraps around you, as if the stars themselves were offering a soft blanket of glowing dust. As we drift farther, the structure of the galaxy begins to reveal itself in wide, serene layers. The thin disk, home to most of the gas, dust, and new stars, shimmers like a glowing ribbon that encircles the galactic center. If you close your eyes, you might imagine the faint smell of cosmic dust, cold and metallic, drifting out of nebulae where stars are born. These stellar nurseries are vast clouds of hydrogen, stretching dozens or even hundreds of light years across. They are dim to our eyes, but through telescopes, they bloom into shapes of violet, rose, and sapphire. Within them, gravity gathers atoms into denser knots, letting them collapse until nuclear fusion ignites. In that silent moment, a star is born, quietly, without fanfare, yet with enough power to outshine entire worlds. We float through such a region now, sensing the gentle pressure of photons on our skin, as though the newborn stars are breathing out warmth. The Milky Way holds millions of these nurseries, each one a cradle of future suns and their swirling planetary systems. You might picture these regions as slow-motion fireworks, expanding and cooling, drifting and reforming, always shaped by gravitational tides. The galaxy is not static, but alive with these cycles, humming at a pace too slow for human senses to perceive. Yet in this dreamlike voyage, we can sense the rhythm, like a heartbeat stretched across light years. Our path carries us toward the Orion Arm, the modest spiral arm in which our solar system resides, It is not one of the grand sweeping arms that define the Milky Way's architecture, but a smaller branch, an interarm spur, quiet, calm, almost humble. And yet, it contains some of the most recognizable constellations in our northern skies. As we drift along its length, we pass by regions of gas, sculpted into shapes that resemble rivers, wings, and intricate pillars. Among them lies the famous Orion Nebula, a cavern glowing with soft violet light. Here, in this stellar nursery, thousands of young stars cluster tightly, like sparks held together by invisible threads. The nebula's light washes over us in gentle waves, its glow so faint, yet so purposeful, that it feels as though the universe is softly exhaling. Nearby, massive blue stars burn with extraordinary intensity, their radiation carving hollow bubbles in the surrounding gas. Though such stars live only a few million years, brief by cosmic standards, they dramatically sculpt their environments, pushing, compressing, and illuminating the dynamic clouds around them. As we float on, imagining these forces at play, we feel the subtle interplay of chaos and harmony that shapes the Milky Way at every scale. The Orion Arm becomes not merely a location, but a quiet corridor of stellar evolution. A gentle rotation carries us closer to the galactic plane, where the density of stars increases until they resemble a glowing mist. The darkness between them is filled with dust, fine grains of carbon and silicates that block starlight and create vast lanes of shadow. These dark nebulae weave across the galaxy like brushstrokes of night. They appear empty, yet within them are the seeds of new stars, hidden from view. We drift along one such dust lane, where only the faintest glints of infrared light betray the warmth of protostars cocooned within. Their surroundings are cold, just a few tens of degrees above absolute zero. But inside, gravity is busy sculpting the next generation of suns. As we move deeper, the dust thickens, and the Milky Way's glow becomes muffled, like moonlight passing through fog. It is peaceful here, quiet enough to feel the immense scale of time. Stars that will one day shine brightly are now only whispers of possibility, and the galaxy holds them patiently. Emerging from the dust, we look back toward the bright arc of the Milky Way stretching across cosmic night. It appears softer now, as though the journey through shadow has taught us to see its glow with new calmness. As we continue, gliding along the Milky Way's luminous river, our path curves gently toward one of the galaxy's most mesmerizing features, its spiral structure, shaped by density waves that ripple through the disk like slow celestial tides. Though stars orbit the galactic center at tremendous speeds, the spiral arms persist, not as fixed material structures, but as patterns, regions, where gas and dust become more crowded, allowing new stars to form more efficiently. Imagine these arms as soft, glowing traffic jams in space. Stars drift in, linger for a time, then move onward, while the pattern itself remains. As we float through one such region, we sense the subtle compression of interstellar clouds, the delicate nudge of gravity coaxing matter into alignment. Nearby, clusters of young stars sparkle like scattered gems. Their blue light, brilliant and energetic, paints the surrounding dust with faint luminescence. The arms are not uniform. They twist and branch, forming spurs like the Orion Arm, where our solar system resides. In this dreamlike voyage, we see the arms from within and above, appreciating their fluid beauty. The spiral pattern becomes not a rigid structure, but a breathing, evolving presence, one that has shaped our corner of the cosmos for billions of years. And as we drift, the soft curve of the arm seems to cradle us, as though the galaxy itself is guiding us through its gentle architecture. Moving onward, we approach the mysterious halo that surrounds the Milky Way, an enormous faint sphere of ancient stars, dark matter, and globular clusters. The halo is elusive, almost ghost-like, extending far beyond the visible disk. Its stars are few and widely spaced, remnants of an earlier era in cosmic history. Many of them formed when the universe was still young, carrying chemical signatures far simpler than those of stars born today. As we drift into this high-altitude galactic realm, the star density thins dramatically. The Milky Way's bright plane becomes a distant band of silver below us, and the void stretches out in all directions, crisp and quiet. In this serene emptiness, we encounter our first globular cluster, a densely packed sphere of hundreds of thousands of stars bound tightly together by gravity. From afar, it resembles a glowing pollen grain suspended in darkness. As we draw closer, the stars reveal themselves as ancient, reddish, and incredibly stable. Their collective glow forms a soft, shimmering shell around the cluster's core. Drifting through this region feels like entering a great cosmic archive, where each star is a page from the earliest chapters of galactic history. The calm is almost overwhelming, as though time itself has slowed to a whisper. Yet even here, in this sparse realm, dark matter exerts its invisible pull, shaping the cluster's motion and stabilizing the galaxy on scales too vast for us to comprehend. We float in silence, held gently by forces we cannot see. Our journey bends slowly inward now, toward the bustling heart of the Milky Way. This central region, called the bulge, swells from the disk like a luminous sphere, dense with stars and saturated with interstellar dust. As we descend from the halo, the density of light increases until it feels like entering a warm, glowing fog. Stars fill the sky in every direction, giants, dwarfs, variables, and remnants, crowded so closely that on a planetary surface within this region, night would never truly fall. The bulge is old, its stars belonging to some of the earliest generations born in the galaxy. Yet, it is not static. Streams of stars orbit in elongated paths, shaped by the gravitational influence of a massive bar structure that cuts across the center. We can sense this movement now, flowing like a steady current beneath our feet. The bar itself acts as a gravitational conveyor belt, funneling gas inward and helping sculpt the spiral arms. Drifting deeper, we encounter clouds of dust, illuminated from within by trapped starlight. These clouds glow in rusty golds and muted ambers, painting the region with warm tones that feel almost hearth-like. Despite the intensity of the environment, the silence remains unbroken, softened by distance and vacuum. There is a gentle comfort in this glowing crowd of suns, a reminder that even the galaxy's most energetic places can cradle stillness when observed from afar. Ahead lies the very center of the Milky Way, where scientific curiosity and cosmic wonder converge. Here resides Sagittarius A, the supermassive black hole anchoring the galaxy's structure. Contrary to its fearsome reputation, from our vantage point, this region feels serene, bathed in the warm haze of surrounding stars. Sagittarius A itself is invisible, a perfectly dark sphere where gravity curves space so strongly that not even light can escape. But around it swirls an accretion zone, hot gas and dust, orbiting at incredible speeds, glowing faintly in infrared and X-ray wavelengths. We approach slowly, observing how stars dance near the center in tight, looping orbits, some whipping around the invisible giant in mere decades. These stars, called S-stars, move with extraordinary precision, their trajectories revealing the black hole's mass and influence. One can imagine them as celestial acrobats, performing in silence, tracing elegant arcs in the void. Yet for all the intense physics at play, the scene feels strangely peaceful, as though wrapped in a soundproof embrace. The gravitational well, deep and commanding, becomes part of the rhythm of the galaxy, a heartbeat that has pulsed steadily for billions of years. In this quiet moment, we acknowledge the paradox that something so powerful can reside at the core of such gentle beauty. And as we drift away from the center, the glow of the bulge softens behind us, like the fading warmth of a cosmic fireplace. Gradually, we rise once more above the galactic plane, observing the Milky Way from an angle where its spiral pattern becomes clear again. From this vantage point, the galaxy resembles a vast celestial pinwheel, its arms swirling gracefully around a radiant core. But now, our attention turns to the interstellar medium, the tenuous mixture of gas, dust, and energetic particles that fills the spaces between stars. It is here that the galaxy breathes. Hot, ionized bubbles form where massive stars explode as supernovae, injecting energy and scattering heavy elements across space. Cooler regions condense into molecular clouds, and within them, new stars are born. The interstellar medium is dynamic, always shifting, expanding, cooling, and recombining. In some places, it is nearly a vacuum. In others, dense enough to obscure entire regions of the galaxy. As we drift through one such cloud, the starlight dims to a gentle haze. The temperature drops, and the quiet deepens, as though the universe has taken a long, slow breath. These clouds are rich with organic molecules, complex carbon-based structures that may serve as precursors to life. Their presence hints at a universal chemistry, a quiet suggestion that life's ingredients are scattered generously through the cosmos. As we move onward, emerging back into clearer space, the stars brighten once more, welcoming us back into the galaxy's luminous river. As our journey continues, we drift into a region where the Milky Way's spiral arms display one of their most delicate features: star clusters. Unlike the dense globular clusters of the halo, these open clusters are youthful gatherings, formed from the same collapsing clouds of gas and dust. They are loose, almost casual associations of stars that will eventually scatter as gravitational tides pull them apart. Yet while they last, they shine with a shared beauty, their members bound by origin, if not by permanence. Imagine gliding gently into such a cluster now, a swarm of blue and white stars suspended in darkness, like fireflies drifting in slow motion. The Pleiades, for example, are much like this, a family of bright young stars surrounded by reflective dust that glows in delicate blue hues. The dust itself is not warm. It merely shines because starlight scatters off its fine grains. As we float through this environment, the universe feels younger, lighter, as though we have stepped into the early pages of a cosmic story. These clusters remind us that stars, like people, are born together, yet walk their own paths over time. Some may form planetary systems rich with possibilities. Others may flare intensely and fade quickly. But in this dreamlike moment, they remain a single community, shining with unbroken clarity. We linger there quietly, feeling the soft radiance brushing against us like a sigh. Leaving the cluster behind, we approach regions shaped by some of the most dramatic events in the galaxy's life cycle: supernova remnants. These sprawling structures are the echoes of massive stars that ended their lives in colossal explosions. Yet, despite their violent origins, supernova remnants possess a strange elegance, their filaments stretching into space like threads of glowing silk. Drifting into one such region, we find ourselves surrounded by arcs of gas, illuminated in reds, greens, and blues, colors shaped by the specific atoms within them, as they are energized by shock waves expanding outward. These shock waves travel through the interstellar medium at tremendous speeds, heating and compressing the gas they encounter. Iron, oxygen, carbon, silicon. These elements, forged in the heart of the dying star, are now spread across the galaxy, destined to become part of new stars, new planets, perhaps even new forms of life. In a way, the remnants serve as both endings and beginnings, marking transitions in the great cycle of matter. The cloud around us glows faintly, its filaments seeming almost alive as they twist under turbulent forces. Yet the silence remains complete, reminding us that even the most powerful cosmic events unfold without sound. The colors shift gently as we drift, and for a moment, the remnant resembles a slowly unfurling flower, a final gift from a long-gone star. Our path carries us deeper into a quieter region, where stars are sparse, and the darkness grows velvety and thick. This is the realm of interarm space, the wide stretches between the Milky Way's spiral arms, where fewer stars form, and older stars drift peacefully. Here the distances between suns stretch wide, and starlight softens into faint, widely spaced points. The emptiness feels gentle, rather than lonely, like a vast ocean whose stillness invites contemplation. As we move through this calm expanse, the Milky Way's spiral structure becomes clearer in our peripheral vision, the glowing arms curving like soft brushstrokes across cosmic canvas. It is in these quieter regions that the influence of dark matter becomes more evident, not directly, for we cannot see it, but through the motion of stars that move faster than the visible mass alone can explain. It is as though an invisible scaffolding threads the galaxy, supporting its rotation and extending well beyond its luminous edge. Drifting through this emptiness, we sense the subtle balance between what is seen and what is unseen. The stars here are older, often reddish, their slow-burning lives stretching across billions of years. They glow with calm endurance, like long-kept lanterns guiding the way through cosmic night. The space between them, though vast, feels serene, giving us room to breathe and simply exist within the galaxy's gentle turning. Eventually, we approach a striking environment where stars show astonishing variety, regions of stellar evolution unfolding side by side. Here, massive blue stars blaze fiercely, living fast and bright before meeting early dramatic ends. Next to them, orange giants swell into bloated spheres, shedding their outer layers into delicate nebulae that shimmer like pale petals in space. We drift into one such planetary nebula now, observing the intricate layers of gas expelled by a dying sun-like star. The central white dwarf, small, brilliant, and hot, illuminates the shell around it, creating patterns that resemble ripples frozen in time. Each ring, each arc, marks a moment of change in the star's final breaths. Nearby, smaller red dwarfs burn quietly with astonishing longevity, their lives stretching trillions of years into the future. These tiny stars, though faint, form the majority of stellar populations in the galaxy. Their calm endurance acts as a steady counterpoint to the short, intense lives of massive stars. As we float between these diverse stellar forms, it feels like wandering through a vast museum of cosmic life cycles, each exhibit lit gently by its own internal fire. The contrasts are beautiful, not harsh, like the harmonious blend of different voices in a whispered choir. Everything here, from the brilliant to the faint, contributes to the Milky Way's slow, timeless rhythm. Our journey brings us now to the edges of a magnificent structure known as a stellar stream, long, delicate rivers of stars stretched across the galaxy by gravitational encounters. These streams are the remnants of smaller galaxies, or clusters that ventured too close to the Milky Way, gradually pulled apart and woven into its structure. As we drift through one such stream, the stars appear aligned like beads on an invisible thread, each following a similar trajectory through space. What was once a compact system has become a graceful ribbon, wrapped around the Milky Way like a celestial sash. The stars here are old, bearing chemical signatures that differ subtly from those formed within the Milky Way itself. They carry memories of distant origins, like travelers who have joined a new land, but retain traces of the places they once called home. Yet the stream itself feels peaceful, its motion smooth and assured. Drifting amid its members, we sense the gentle tug of the galaxy's gravity, guiding them along elongated paths. The stream stretches far beyond our sight, looping around the galaxy in arcs that take billions of years to complete. In this tranquil passage, we are reminded of the Milky Way's ability to absorb, reshape, and incorporate countless histories into its own. Every star here tells a quiet story of transformation, one that mirrors the galaxy's ever-evolving nature. As we drift farther along the Milky Way's luminous pathways, we approach regions where star formation and destruction coexist in a delicate cosmic balance. Here, immense molecular clouds spread like shadowy continents across interstellar space. These clouds, often hundreds of light years across, contain dense knots where gravity is quietly gathering matter, into new stars. Elsewhere within them, turbulent currents, generated by winds from massive stars or ancient supernovae, carve intricate hollows and filaments. We glide into one of these vast clouds now, the darkness so thick it seems to absorb the surrounding light. Yet within this darkness lie faint glimmers, embryonic stars hidden deep inside pockets of cold gas. These protostars, though invisible to human eyes, radiate a soft infrared warmth that hints at the life they are beginning to forge. As we move gently through the interior of the cloud, the silence feels different, more intimate, like standing backstage in the universe's workshop. You might imagine the far-off creak of gravity tugging gently on matter, or the subtle hiss of gas, shifting as new suns prepare to awaken. Emerging slowly from the cloud's edge, we witness once more the radiant face of the Milky Way, glowing with the soft promise of stars yet to be born. Continuing through this stellar landscape, we enter a realm shaped by magnetic fields, those invisible threading forces that subtly guide the motion of charged particles throughout the galaxy. Although magnetic fields are weak compared to gravity, they influence the formation of dense filaments in molecular clouds and help steer cosmic rays as they race through interstellar space. As we drift now through an area where these fields are especially pronounced, the gas around us appears to align into thin, elongated structures. It is as though the galaxy's unseen architecture is becoming visible for a moment, etched into space by the patterns of dust. In this dreamlike perception, the fields resemble delicate harp strings, vibrating softly under the influence of starlight and motion. Nearby, charged particles spiral along these invisible lines, creating faint glows detectable only in radio wavelengths. Though we cannot hear the music of these interactions, we can imagine it, a gentle, humming resonance, born from interactions too subtle for ordinary senses. And yet, without such fields, star formation would unfold differently. Gas would collapse more quickly, more chaotically. The magnetic presence provides just enough resistance to shape the galaxy's tempo. Floating through this region, we sense that the Milky Way is not only luminous, but also finely tuned, its harmony maintained by forces both powerful and delicate. Our journey bends toward another fascinating domain, the galactic warp. Although the Milky Way often appears in illustrations as a perfectly flat disk, its outer regions are gently bent, forming a subtle, wave-like shape. Several forces may contribute to this warp: the gravitational pull of nearby satellite galaxies, interactions with dark matter, or even oscillations triggered by ancient collisions. As we rise above the plane, the irregularity becomes clear. The disk dips and lifts like a slow rippling ribbon, giving the galaxy a graceful asymmetry. From our vantage point, the warp adds a poetic imperfection, reminding us that even vast cosmic structures bear the marks of experience. Drifting along the elevated outskirts of the disk, we pass through regions where the star density thins, replaced by chilly hydrogen gas, stretching far into the galactic outskirts. This gas, though diffuse, provides clues to the Milky Way's past, its collisions, mergers, and encounters with smaller galaxies that once passed too close. The warp becomes a record of those ancient events, preserved not in written form, but in the delicate bending of structure. The stars here move with slow confidence, tracing orbits that tilt slightly above or below the plane, contributing to the galaxy's overall rhythm. In this quiet domain, the Milky Way feels more like a living entity, shaped by its history, always adapting, always shifting with the gentle tides of the cosmos. From the warped outskirts, we turn toward the faint but widespread component known as the thick disk. This region sits above and below the thin disk, populated by older stars whose orbits tilt and wobble compared to the orderly paths of younger populations. As we drift into the thick disk, the starlight changes subtly. The stars around us glow with warmer hues, their chemical compositions reflecting an earlier era of the galaxy when heavy elements were less abundant. These stars move with greater velocity dispersion. They do not follow the neat circular paths of stars nearer the galactic plane, but instead wander in slightly jagged motions that trace the galaxy's gravitational history. Some theories suggest that the thick disk formed during an ancient merger event when a smaller galaxy collided with the Milky Way, stirring its stars into more chaotic orbits. Others propose more gradual origins, shaped by long-term heating and internal evolution. As we glide through this region, the motions appear slow and drifting, but behind this tranquility lies the echo of ancient upheavals. Each star here is a tiny artifact of the past, a glowing record of epochs long vanished. The thick disk feels contemplative, like walking through a quiet hall of memories where nothing speaks, but everything tells a story. Finally, our path brings us toward the galactic outskirts, those remote, whisper-quiet regions where the Milky Way fades into darkness and the boundary between galaxy and intergalactic space becomes wonderfully ambiguous. The density of stars here dwindles to almost nothing. The void stretches open, clean and crisp, yet not empty. Sparse clusters of neutral hydrogen float in great clouds, shaped by gravitational tides from the galaxy and its companions. Far below us, the Milky Way's spiral arms glow like faint, distant trails, a reminder of the vibrant structure we have been exploring. Up here, at the galaxy's rim, we can sense the subtle pull between the Milky Way and the surrounding local group of galaxies. The gravitational influence of the Andromeda Galaxy tugs faintly at our home, even across millions of light years. Tiny satellite galaxies, like the Sagittarius Dwarf or the Magellanic Clouds, leave delicate imprints on the outskirts. Streams of stars stretched across the void, like quiet echoes of their passing. As we drift into this transition zone, the silence becomes exquisite, as if the universe were drawing a long, peaceful breath. It is a place of endings and beginnings, where the Milky Way's identity blends into the wider cosmic web. And as we look back toward the luminous river behind us, it feels as though we have wandered far from shore, yet still feel the warm glow of home. As we linger in the outskirts of the Milky Way, our path begins to curve inward again, not toward the violent heart of the galaxy this time, but towards something more subtle and intimate, the quiet story of planets. For much of our journey, we have floated among stars themselves, luminous furnaces of plasma blazing in the dark. But around so many of these stars, invisible in the distance, worlds circle silently. They do not shine with their own light. They borrow it, reflecting faint glimmers back into space. Astronomers have confirmed thousands of exoplanets in our galaxy, and suspect there may be trillions more, each one a small private stage where gravity and chemistry write unique stories. As we drift closer to a typical star in the galactic disk, we imagine its planets as soft silhouettes crossing the stellar face, dimming the light by the tiniest fraction, just enough for patient instruments to notice. Some worlds are scorched and close, locked in perpetual daylight on one side and endless night on the other. Others are distant and frozen, where starlight is only a pale memory. Between them lies a delicate band, a region where temperatures might allow liquid water to exist. We hover there in our thoughts, in that quiet temperate zone, and wonder how many oceans, how many clouds, how many skies the Milky Way carries, hidden like tender secrets in the dark. As we continue, we begin to sense a broader pattern. The idea of a galactic habitable zone, a region in the Milky Way where conditions may be especially favorable for complex life. Too close to the galactic center, and the density of stars, supernovae, and energetic events becomes intense. Bathing space in frequent radiation storms that could sterilize fragile worlds. Too far in the distant outskirts, and the supply of heavy elements, those forged in previous generations of stars, grows thin, making the formation of rocky planets less likely. Our sun orbits in a kind of gentle middle ground, neither too crowded nor too barren, where chemical richness and relative calm coexist. We drift through this conceptual ring now, imagining countless suns scattered within it, each perhaps encircled by planets with surfaces, weather, and silent landscapes. Most of these worlds will never know visitors, never be seen by any eye, yet they exist, quietly participating in the galaxy's grand experiment. Perhaps some host life, humble or complex. Perhaps others are still only waiting, their elements slowly assembling into molecules that over unimaginable spans of time might begin to copy themselves, to adapt, to feel. The Milky Way, seen this way, is not only a river of light, but a vast, quiet garden of possibilities. Our path now bends toward the subject of time itself, the deep, almost unfathomable timescales over which the galaxy evolves and stars live and die. As we float past older stars, whose lives stretch back nearly to the Milky Way's earliest days, we are reminded that our own existence occupies only a fleeting moment. The sun is about halfway through its stable life on the main sequence, having already burned steadily for billions of years, with billions more to come. Around us in this imagined voyage, we see stars of many ages, each one like a clock that began ticking when its nuclear fires first ignited. Massive blue stars live fast, burning through their fuel in a few million years, exploding in brilliant supernovae almost as quickly as they appeared. Smaller red dwarfs, by contrast, sip their fuel with extreme patience and could shine for trillions of years, far longer than the current age of the universe. As we contemplate these different clocks, the galaxy fills with overlapping rhythms, short, intense beats, long, sustained tones, and steady, middle voices like our own sun. In this slow symphony, our human lifetimes are tiny, almost imperceptible notes, yet they are still part of the music, drifting here, wrapped in the awareness of these colossal spans of time. We feel something soften inside us. The worries bound to our brief years loosen, just a little, as we remember that the Milky Way has been turning calmly long before us, and will keep turning long after. We approach now a region where stars appear familiar, not because we have visited them before, but because of the patterns they form in our sky. From Earth, humans have, for thousands of years, connected bright points into constellations, figures of animals, heroes, instruments, and stories traced across the night. As we drift above the galactic plane and look back toward the sun's neighborhood, we imagine how these constellations would shimmer into existence when viewed from our home world. Orion, with his belt and sword; Cygnus, the swan gliding along the Milky Way; Scorpius, curling near the galactic center. Each pattern is an illusion of perspective. Stars separated by dozens or hundreds of light years appear close together from our vantage point. Now, in this journey, we move among them, recognizing how scattered and independent they truly are. Yet the stories drawn between them are no less real for being illusions. They are evidence of consciousness, of minds on a small planet, looking up and weaving meaning into the sky. The Milky Way becomes not only a physical river of stars, but also a cultural river, carrying myths, calendars, navigation routes, and dreams. As we float in this region, we feel the presence of all those quiet observers throughout history, standing beneath the night and feeling something open within them at the sight of the galaxy's pale arc. From here, we glide toward the quieter, more personal side of the Milky Way, the way its gentle glow affects a single resting mind. Imagine lying beneath a truly dark sky, far from city lights, where the Milky Way spills clearly from horizon to horizon. At first, the brightness might surprise you, such a rich band of light, where in cities, there is only darkness. As your eyes adjust, thousands of stars resolve from the haze, and the river of light seems to gain depth, like a mist you could sink into. In that moment, your breathing slows almost on its own. The sense of being small emerges, but it is not frightening. Instead, it is relieving. like setting down a heavy bag you had forgotten you were carrying. The galaxy does not demand anything of you. It simply turns, patiently, as it has done for eons. Our journey through the Milky Way, in this story, mirrors that feeling. We have visited its core, its arms, its halo, its nurseries, and its remnants. Now, floating in the soft light of its river, we allow that vastness to soothe us. The stars do not rush. The orbits do not hurry. Everything moves at a pace too slow to disturb sleep. You are part of this galaxy, a small but genuine piece of its unfolding story, and as you rest, the Milky Way continues to turn gently around you, a luminous river carrying you deeper into quiet. As we drift onward from the gentle reflections of our previous passage, our journey now enters a region where the Milky Way's dust becomes a quiet sculptor of light. These dust lanes, dark, thread-like structures woven through the galaxy, are not mere obstacles to starlight, but essential tools that shape how we see the universe. We float now into one such lane, a broad and shadowed corridor stretching for hundreds of light years. Within it, microscopic grains of carbon and silicates scatter and absorb the glow of nearby stars, dimming some wavelengths while allowing others to pass through. The darkness here feels soft rather than empty, like velvet pressed gently against the skin. And as our eyes adjust to the subdued twilight, new details emerge, faint glimmers of background stars, warm infrared hazes, where dust absorbs energy and re-emits it in longer wavelengths. Dust is often misunderstood as something that hides beauty, but in truth, it creates contrast, allowing galaxies to develop depth, character, and dramatic silhouettes. Without dust, nebulae would not shine, planets might not form, and the storytelling texture of the Milky Way would fade into uniform brightness. Moving through this dusky corridor feels like stepping behind the scenes of the galaxy's artistry, watching the subtle brushstrokes that make its luminous river so enchanting from afar. As we emerge from the dust, a new vista opens, the broad, sweeping bridge of the Sagittarius Stream, one of the largest stellar streams encircling the galaxy. This gentle arc is the remnant of a dwarf galaxy, currently being absorbed by the Milky Way. We drift alongside its ribbon-like structure, noticing how its stars move in synchronized orbits, their trajectories wrapping gracefully around the galactic halo. These stellar travelers carry within their chemical signatures the history of a smaller world, one where star formation followed a quieter, slower path than in the Milky Way. Because of this, the stars of the Sagittarius Stream have distinct elemental compositions, allowing astronomers to trace their origin with precision. We glide deeper into the stream, feeling the elegance of its motion, not violent, not chaotic, but patient, as though the Milky Way is gently welcoming these stars into its vast family. Over billions of years, the stream will dissolve completely, its stars fully blended into the halo, their origins remembered only by the patterns left behind. In drifting through this structure, we witness the galaxy's ongoing growth, not through sudden upheaval, but through soft, continuous merging, a slow dance of gravitational embrace. Our path now bends toward a realm where the physics of the universe grows more exotic. The domain of cosmic rays, these high-energy particles, accelerated by supernova shocks and other extreme events, race through the galaxy at nearly the speed of light. Though invisible to our eyes, their presence fills the Milky Way like a faint, energetic breeze. As we drift through this environment, we feel, not physically, but conceptually, the constant motion of these tiny travelers. Protons, electrons, and atomic nuclei streak past us, each carrying the signature of its birthplace. Some originated in the explosive death of massive stars. Others may have been hurled into motion near black holes or magnetized neutron stars. Despite their speed, they are not chaotic. Large-scale magnetic fields guide them, bending their trajectories into meandering, spiral paths throughout the galaxy. In this imagined voyage, The cosmic rays feel like whispers from distant, energetic events, soft reminders of the galaxy's powerful moments, filtered through unimaginable distances and time. And yet, even here, within this energetic sea, the sense of calm persists. The galaxy's extremes, when viewed with wide perspective, fold gently into the same serene rhythm that defines all of cosmic evolution. Continuing our journey, we arrive in a region shaped by the subtle interplay between stars and the diffuse gas around them. This is the territory of superbles, enormous cavities carved into the interstellar medium by clusters of massive stars. When multiple supernovae erupt within the same region over millions of years, their shock waves join forces, sweeping gas outward and creating vast hot bubbles that span hundreds of light years. We drift into one such structure now, its boundaries faint and glowing with soft X-ray emissions. Inside, the gas is thin and hot, yet the emptiness feels peaceful, like the hollow interior of an ancient shell. The edges of the superbubble shimmer with dense walls of swept-up material, where future generations of stars may eventually take shape. These cycles of carving and rebuilding, of explosion and renewal, are part of the galaxy's quiet metabolism. The superbubble does not feel violent from our vantage point. Instead, it feels like a cathedral of space, vast and echoing, shaped by long-forgotten stars whose final breaths continue to sculpt the cosmos. As we float through its interior, the scale of it fills us not with fear, but with a deep, meditative awe. At last, we drift into a region where the Milky Way's rotation becomes something we can sense, conceptually, quietly, like a deep cosmic current. Every star, every cloud, every grain of dust participates in the turning of the galaxy around its core. This rotation is not uniform. Stars closer to the center travel faster, while those farther out move with calm steadiness, guided by the mysterious influence of dark matter. We hover now among stars that share our sun's orbital distance, imagining the slow, stately journey they take around the galactic center. One full orbit here takes roughly 220 million years. Humans evolved, civilizations rose and fell, and continents drifted across Earth's surface, all during a single sweep of this cosmic path. As we contemplate this rotation, we sense the Milky Way not as a fixed image, but as a living motion, a vast, spiraling river, flowing endlessly, but too slowly for a single lifetime to perceive. And within that motion, our own presence feels small, yes, but not insignificant. We are participants in the galaxy's long, graceful turning, companions to stars, dust, and distant worlds on this immense journey through space. As we continue drifting along the outermost edges of the Milky Way, our path bends toward the graceful arcs of the galaxy's tidal streams, vast, delicate ribbons of stars that trace ancient interactions with smaller companion galaxies. Here, the gravitational embrace of the Milky Way stretches these visitors into long, trailing currents that loop around the galactic halo. We glide now through one such stream, where stars move in cohesive formation, yet retain subtle variations that hint at their shared origins. They appear softer here, as though the long journey through intergalactic space has smoothed their brilliance into a calm glow. Each star whispers of its past, of the time when it belonged to a compact cluster or dwarf galaxy, of the moment it was drawn into the Milky Way's influence, and of the quiet, graceful unraveling that followed. The stream curves like a pale ribbon through darkness, and we drift along its length with unhurried ease. It feels almost like walking through a cosmic memory, a story told not with words but with motion and light. At this great altitude above the galactic disk, the Milky Way itself becomes a luminous archway beneath us, and the stream becomes a bridge that ties its history to the vast expanse beyond. Leaving the tidal stream behind, we venture into a region where the intergalactic medium begins to mingle with the galaxy's farthest gas reserves. Out here, the density of particles is incredibly low, far lower than any vacuum achievable on Earth. Yet this space is not truly empty. It is filled with intergalactic gas, thin wisps of plasma, stretching between galaxies like ghostly threads. These particles move slowly under the influence of gravity and large-scale cosmic structures. As we drift among them, we sense the enormous calm of intergalactic space. The Milky Way's glow, now distant and serene, forms a pale crescent far behind us. Ahead, faint glimmers hint at the presence of other galaxies, the closest of which lie millions of light-years away. Though their light barely grazes this region, the gravitational pull between galaxies creates subtle tides that shape the motions of these thin clouds. The intergalactic medium is infused with background radiation, the faint afterglow of the Big Bang, stretching across all of space like a soft thermal hum. Here, in this slow, gentle environment, the galaxy feels less like a dominant structure and more like one star among many in a surrounding cosmic archipelago. The quiet is deeper than anything encountered before, a stillness so complete it seems to dissolve even the sense of motion. We turn now back toward the Milky Way, following the faint gravitational gradient that guides objects toward the galactic center. As we approach the disk once more, we encounter star-forming rings, vast rings of gas and dust that circle the inner regions of the galaxy. These rings often arise from the influence of the galactic bar, which funnels gas inward along certain pathways. The material accumulates at resonant radii, forming dense, rotating bands where star formation becomes intense. We descend gently into such a ring, and the contrast with the intergalactic quiet is immediate. Here, the gas is rich and fragrant with hydrogen. Stellar nurseries bloom everywhere, and the warm glow of young clusters radiates outward like lanterns in a cosmic garden. Winds from newly formed stars create bubble-like cavities in the surrounding gas, shaping the ring into a patchwork of glowing voids and dense filaments. As we drift around the circumference of this structure, we notice how the ring's rotation pulls everything along in a smooth, rhythmic dance. The stars born here will eventually migrate outward or inward, but in this moment, they form a luminous necklace encircling the galaxy's inner regions. The ring feels alive, vibrant, and bustling, a place where the universe's creativity flourishes in quiet abundance. Our journey arcs farther inward, carrying us back into the richly textured galactic disk. Here we encounter the spiral arms once more, but now with deeper understanding and a sense of returning home. We float through star fields, bright and dense, where stellar populations of all ages intermingle. Blue giants blaze fiercely near their birthplaces. Orange giants expand gracefully in their late stages of life. Yellow stars like our sun move steadily along their orbits, and everywhere, tiny red dwarfs flicker patiently, the quiet workhorses of the galaxy. As we drift among these diverse stellar forms, we begin to appreciate the grand continuity that underlies them. No star is isolated in its story. Each one contributes mass, radiation, momentum, and chemistry to the galaxy's ongoing evolution. Supernovae enrich the surrounding clouds. Stellar winds shape the trajectories of dust. Planetary systems sculpt belts of debris that over billions of years may evolve into worlds capable of oceans, landscapes, and perhaps life. The spiral arms feel like veins carrying starlight instead of blood, nourishing the Milky Way with energy and renewal. Moving deeper into their glowing corridors, we sense the comforting familiarity of the place we ultimately belong to, a home not just for our solar system, but for billions upon billions of stars, forming the luminous river we call the night sky. At last, our path brings us gently back toward the Orion Arm, the modest spur of the Milky Way, where our solar system resides. After journeying through distant halos, tidal streams, and luminous rings, this return feels like stepping back into a familiar neighborhood after a long, reflective voyage. The stars around us thin into recognizable patterns, and the soft glow of nebulae highlights the vibrant creativity of this region. We pass once more near the Orion Nebula, where thousands of young stars shimmer behind curtains of violet dust. Then, drifting past the Pleiades-like cluster of our earlier travels, we begin to sense the comforting gravitational pull of the sun. The solar system approaches like a welcoming lantern in the vast dark, its planets orbiting in quiet harmony. Earth appears as a delicate blue sphere, wrapped in clouds and oceans, illuminated by the warmth of our middle-aged yellow star. As we settle beside it again, the Milky Way stretches across the sky like a familiar river, yet it now carries new meaning. We have seen its center, its outskirts, its nurseries, and its remnants. We have drifted through cycles of birth, transformation, and dissolution, and now returning home, we carry the calm of that cosmic understanding within us, a gentle, steadying peace, shaped by the galaxy's rhythm. Thank you, dear traveler, for drifting with me through this long, luminous journey across the Milky Way. Your presence here, your willingness to explore science through softness and wonder, is what allows this channel to grow. Every subscription, every like, every gentle comment helps this small corner of calm reach others who may need rest, curiosity, or simply a peaceful moment beneath the stars. I am deeply grateful for your company among these cosmic currents. And now, our journey comes to rest. The galaxy settles into stillness around you, its spiral arms dimming into a soft hush. Stars breathe quietly in the distance, drifting on their ancient paths. The universe sleeps, and you drift with it, wrapped in the calm of starlight and silence. May your thoughts become as light as nebulae, your breath as slow as the turning of the galaxy. Rest now, traveler of the luminous river. The night carries you gently home.